Have you ever just stopped and wondered what's really going on inside those massive, complex industrial machines that, make our modern world go round? It's this hidden universe of electrical signals, ultra-precise control, and a lot of unsung heroes. Well, today, we're going to pull back the curtain on one of those key players, the DC solid-state relay.
So here's the plan. We're going to start with the big picture, the whole machine. Then we're going to zoom way down to this one tiny critical component, and then we'll pull back out to see how it all clicks together. Sound good? Let's go.
All right, so to really get why this little component is so important, we first have to get a handle on the sheer scale of the problem it's designed to solve.
I want you to think about it like this. Imagine you're trying to conduct a massive orchestra, maybe with thousands of musicians. Every single note has to be absolutely perfect, every single time, for literally millions of performances. That's what we're talking about here. It's an incredible symphony of electrical control.
Okay, so take a look at this. This gives you a little peek into the machine's nerve center, its main control cabinet. I mean, it looks complicated, right? And it is. But here's the secret. To understand the entire system, you don't have to tackle it all at once. We can just focus on one tiny part, and that's exactly what we're going to do. All right, let's move away from the big abstract idea of control and get down to a real practical example right from the machine's own blueprints. Making something hot. We're just going to look at how this machine controls a simple heater.
This diagram is just brilliant because it shows a really fundamental idea in industrial control. See over on the left, you've got the low voltage control CKT, or control circuit. That's the brains, right? It runs on safe, low power. Then on the right, you've got the high voltage power CKT. That's the brawn that actually does the work and runs the heater. So, the million-dollar question is, how do you get the low power brain to safely tell the high power brawn what to do? You need a bridge. And look right there in the middle of it all. There's our component, SSR V851.
Okay, so this SSR thing, this is the hero of our story. But what is it exactly? Well, it stands for Solid State Relay, and honestly, it's a total game changer.
Put simply, it's a switch, but with no moving parts. It uses the, kind of magic of semiconductor physics to turn a circuit on and off. It's silent, it's instant, and it's incredibly reliable. Think about an old-school light switch. The one that makes that loud click sound? That's basically an old electromechanical relay. It has physical parts that move, and because they move, they wear out and eventually break. An SSR, on the other hand, is more like the touch sensor on your phone. It's completely silent, there's nothing to wear out, and it can switch on and off millions and millions of times without ever failing. And that's not just a nice to have. In a factory, one single busted mechanical relay can shut down an entire production line. We're talking thousands of dollars a minute down the drain. So yeah, the reliability of an SSR, it's a huge, huge deal.
Okay, now we get to the really cool part. We're going to metaphorically crack this thing open and take a look at the internal architecture of the DC SSR to see exactly how it pulls off this magic trick.
And here it is, the blueprint, straight from the source documents. This shows us that the SSR isn't just one simple thing. It's a complete, intelligent system. It has its own logic, its own power handling section, and its own power supply, all crammed into this one little package. This isn't just a switch. It's a tiny microsystem with a very important job.
So how does it all work? Let's walk through it. First, a tiny control signal, maybe from the machine's main computer, comes in. The logical part of the SSR, the control and diagnostic blocks, receives that signal. If everything looks good, it gives the go signal to the power section. Now, the heart of that power section is something called a MOSFET, which is basically just an incredibly fast electronic gate. When it gets the signal, that gate swings open, and whoosh, the high-voltage DC power flows right through to turn on our heater. It's the brains telling the brawn exactly what to do, all happening at nearly the speed of light.
But wait, there's more. The SSR isn't just a super-fast switch, it's also a bodyguard. One of its most critical jobs is to provide smart protection for the machine. So, according to the documents, this DC SSR is packed with built-in safety features. It has a current limiter, which basically stops something like a heater from getting greedy and drawing too much power, which could burn it out. It's got overvoltage protection to shield it from any nasty power spikes on the line, and it even has its own internal diagnostics, so it's constantly checking on its own health. Pretty smart, right? And this whole protective mindset is baked into the entire machine's design. This quote, for example, from the parts list, talks about using a simple resistor to protect a motor from overheating.
It just goes to show you that every single part of the system, including our SSR, is designed from the ground up with durability and self-preservation in mind.
Okay, so we've looked at the theory, we've peeked inside at the architecture, and we've seen the safety features. Now let's zoom back out and see how this little guy actually plugs into the machine's real-world electrical diagrams.
And there it is, a page right out of the machine's official schematics. You can literally trace the path. See the 24-volt DC input coming in from the rectifier? That's what's powering our control circuit. And then you can follow the output lines, like V868 and V869, as they go off to control different parts of the machine. This is it. This is the real-world proof of everything we've been talking about, showing the SSR right there in its natural habitat, just quietly and faithfully doing its job.
So what's the big takeaway here? The DC solid-state relay is so much more than a simple on-off switch. It's a smart, super fast, and durable little device that creates a safe and protective link between the machine's low-power computer brain and its high-power muzzles. It's an absolutely essential piece of the puzzle for modern, reliable industrial automation.
It really makes you think, doesn't it? As we saw today, sometimes the most unassuming, simple-looking components are the ones doing the most important jobs. So I'll leave you with this. What other silent heroes are hidden away inside the technology we all rely on every single day?
Thanks for watching, and please like, share and subscribe for such more content and appreciation. Make sure to comment your questions and